SpaceX has changed the space industry forever by doing something no private company had ever done before. In less than 20 years, it went from a small startup to making NASA look like a complete failure. Today, SpaceX is the main launch provider for the United States, and what they have been doing recently is truly mind-blowing. In this video, we are going to look at how SpaceX reached this point and why their latest achievements are changing spaceflight again. Before we begin, make sure to subscribe to the channel for more updates on SpaceX's groundbreaking missions and future plans. NASA, without a doubt, had been leading the space race for decades. In the 1960s, NASA built the Saturn V rocket and used it to send 12 astronauts to the moon between 1969 and 1972. The Saturn V produced about 34 million newtons of thrust and remains the most powerful rocket ever flown successfully. No other program before or after managed to send humans beyond low Earth orbit so many times in such a short period. After the Moon program ended, NASA shifted its focus to long-term missions in Earth orbit. In 1981, NASA began flying the Space Shuttle. Over the next 30 years, the shuttle completed 135 missions and carried more than 350 astronauts into space. It delivered the Hubble Space Telescope in 1990 and later repaired it on 5 separate missions. The shuttle also built most of the International Space Station. More than 30 shuttle flights were used to assemble the ISS between 1998 and 2011. But the shuttle system turned out to be far more expensive and dangerous than expected. Each launch cost more than $1 billion when operations and maintenance were included. In 1986, Challenger exploded shortly after liftoff, killing all 7 astronauts on board. In 2003, Columbia broke apart during re-entry, again killing 7 astronauts. After each accident, the entire fleet was grounded for long periods. When the Space Shuttle was retired in 2011, the United States lost the ability to launch its own astronauts. For the next 9 years, NASA depended entirely on Russia's Soyuz spacecraft to reach the International Space Station. During this period, NASA paid between $70 and $90 million for every astronaut seat and spent more than $3.5 billion in total to send U.S. crews to orbit. At the same time, NASA was trying to replace the shuttle with a new system. Development of the Orion spacecraft began in 2006, and the Space Launch System rocket was approved in 2011. By 2020, NASA had already spent more than $20 billion on these 2 programs. The first uncrewed Orion mission did not fly until November 2022, 16 years after development began. As of 2026, Orion has still not flown a single crewed mission, and SLS has launched only 2 times, with each flight costing around $4 billion and planned at a rate of about 1 launch every 1 to 2 years. SpaceX entered the picture much later. In 2014, NASA selected SpaceX to build a cruise spacecraft under the Commercial Crew Program. In only 6 years, SpaceX designed Crew Dragon, tested it, and flew astronauts to orbit. In May 2020, Crew Dragon carried 2 NASA astronauts to the International Space Station. This ended the 9-year period where the U.S. depended on Russia for human launches. Since then, Crew Dragon has become NASA's main crew vehicle. By early 2026, it had flown more than 10 crewed missions and carried over 40 astronauts safely. Each seat costs NASA about $55 million, which is much cheaper than what NASA paid for Soyuz. The way SpaceX builds hardware is very different from how NASA traditionally works. A good example is the docking system used to connect spacecraft to the space station. NASA's older designs used powered motors and several custom-built actuators. At SpaceX, engineers redesigned the docking system using mechanical springs instead of powered motors and actuators. NASA's older docking systems use 6 electric actuators, multiple position sensors, control computers, and backup power systems. Each actuator weighed several kilograms and cost tens of thousands of dollars. The full docking ring had more than 100 individual parts that could fail. SpaceX replaced this with a passive capture system using mechanical springs that weigh only a few kilograms in total and require zero electrical power during capture. The number of active moving parts was reduced by more than 70%. Since Crew Dragon first docked with the ISS in 2020, the system has been used more than 10 times with a 100% success rate and zero docking failures. The same approach explains why SpaceX's rockets are far ahead of NASA's rockets in daily operations. NASA's space launch system is based on Space Shuttle technology from the 1970s and 1980s. The main engines were originally designed over 50 years ago. The solid rocket boosters are upgraded shuttle boosters. Almost all of the rocket is thrown away after each launch. Each SLS launch costs around $4 billion. As of 2026, SLS has flown only 2 missions, and NASA expects to launch it about once every 1 or 2 years because it is so expensive and slow to build. SpaceX's Falcon 9 tells a completely different story. Falcon 9 first launched in 2010. By early 2026, it had flown more than 600 times. In 2023 and 2024 alone, SpaceX launched more than 90 orbital missions per year, more than any country or company in history. The reason is reuse. Falcon 9 boosters land back on Earth and are flown again. Some boosters have flown more than 20 missions. This reduces costs and allows SpaceX to launch much more often. A Falcon 9 launch sells for about $67 million. In comparison, one SLS launch costs the same as about 60 Falcon 9 launches. Falcon Heavy, SpaceX's larger rocket, can lift more than 63 tons to low Earth orbit and costs around $150 million per launch. SLS can lift more, but at more than 20 times the price. SpaceX did not just beat NASA. It also beat the biggest aerospace companies in the world, especially Boeing. In 2014, NASA selected both SpaceX and Boeing under the Commercial Crew Program. Boeing received $4.2 billion to build the Starliner capsule. SpaceX received $2.6 billion to build Crew Dragon. Boeing had decades of human spaceflight experience from the Space Shuttle program, and Starliner was meant to compete directly with Dragon. Starliner quickly became one of the most troubled crew programs NASA has funded. The first uncrewed Starliner test flight in December 2019 failed. A software timing error caused the capsule to burn too much fuel and miss its planned docking with the International Space Station. NASA later found more than 80 serious software and integration problems. Boeing had to repeat the test flight at its own expense. The second uncrewed flight in May 2022 docked with the ISS, but several maneuvering thrusters failed during approach, and engineers found problems with valves and propulsion systems after the mission. By June 2024, Boeing finally attempted its first crewed flight, more than 5 years behind schedule, and after spending over $6 billion. That mission failed. Soon after launch, engineers detected multiple helium leaks and failures in Starliner's propulsion system. At least 5 thrusters stopped working. NASA ruled that the capsule was not safe for re-entry. The mission was planned to last 8 days. Instead, the 2 astronauts, Butch Wilmore and Suni Williams, remained on the ISS for about 9 months because Starliner could not safely bring them back. NASA then turned to SpaceX. In early 2025, a Crew Dragon spacecraft launched, docked normally with the ISS, and returned both astronauts safely to Earth. By this point, the result was clear. Crew Dragon first flew astronauts in 2020. By 2026, it had completed more than 10 crewed missions and carried over 40 astronauts with 0 crew losses. Now SpaceX is building Starship, the largest rocket ever designed. Starship is meant to be fully reusable, including both the booster and the spacecraft. It uses stainless steel instead of expensive materials. Each Raptor engine produces about 230 tons of thrust, and the booster uses 33 engines at once. By early 2026, Starship had already completed several full test flights and had shown controlled re-entry and booster recovery attempts using mechanical arms on the launch tower. No government rocket has ever tried to recover and reuse stages at this scale. SpaceX's long-term goal is to reduce launch costs to a few $100s per kilogram. Today, Falcon 9 already launches payloads for less than $3,000 per kilogram. SLS costs are estimated to be above $20,000 per kilogram. The reason for this gap is not funding. NASA's yearly budget is about $25 billion. SpaceX operates with far less. The difference comes from speed and design choices. And that's it for this video. Thanks for watching, and I'll see you in the next one.